One of the most perplexing discoveries in recent astronomical history began when a signal from deep space appeared to arrive before it should have even existed, detected by the James Webb Space Telescope. This phenomenon has left scientists grappling with questions that challenge the very foundation of physics. While studying the galaxy cluster SMACS 0723, Webb's instruments captured light from a distant, gravitationally lensed galaxy. What stunned researchers was that this galaxy exhibited structural maturity that didn't align with its distance, meaning it appeared older than the universe should allow at that location in time. This strange event, now referred to as the pre-echo effect, has sparked intense debate and fascination within the scientific community. It suggests either a serious flaw in our current understanding of time's flow, or the existence of information that somehow travels backward through space-time. Initially, researchers suspected a technical glitch. Dr. Jane Rigby, a scientist on the Webb operations team, noted that their first instinct was to assume a calibration error, but after repeated verification and independent analyses, they had to confront a disturbing truth. The data was genuine. This detection occurred during Webb's deep field observations, which revealed unprecedented cosmic detail. The galaxy in question simply shouldn't appear the way it does, and yet it does, defying expectations about cosmic evolution and the nature of time. Things only became more bizarre from there. The key to this discovery was gravitational lensing, a process where massive foreground galaxy clusters bend and magnify light from background objects. In Webb's data, one such ring, the result of perfect alignment between a distant galaxy, a lensing cluster, and the telescope, looked nearly flawless. But one segment of the ring didn't behave as expected. According to Einstein's general relativity, light passing near massive objects should arrive with predictable delays due to time dilation. However, this portion of the ring arrived early, and it appeared slightly bluer than it should have, suggesting the light had somehow moved faster through space-time than allowed by any known laws. Dr. Katie Booman, an imaging expert at Caltech, confirmed that they had thoroughly reviewed the data and found no explanation in conventional physics. It seemed as if information from this galaxy had taken a shortcut through the universe. Theories once confined to speculative physics, closed time-like curves, quantum retrocausality, or even traversable wormholes suddenly seemed possible. According to theoretical physicist Dr. Nima Arkani Hamed, this might be the first time we've seen real-world evidence of such exotic space-time behavior. The mystery deepened when scientists applied quantum denoising filters, tools originally built to search for dark matter, to the light signal from the galaxy. They expected random quantum noise. Instead, they discovered repeating, structured patterns within the signal. These weren't random fluctuations, but rather highly organized data sequences, appearing and vanishing with precise mathematical timing. It was as though the light carried an encoded message. Initially, researchers considered whether this might result from exotic particles decaying into photons. Axions or other dark matter candidates could explain such emissions, but then another theory emerged. The universe itself might operate like a quantum computer. MIT physicist Dr. Seth Lloyd has suggested that cosmic structures could function as components of a vast quantum processor. Dr. Priyamvada Natarajan of Yale proposed that the observed signal patterns might represent computation occurring on the quantum level of space-time, code embedded in the cosmos itself. As if that weren't enough, additional data pointed to an even more extraordinary reality. Analyzing the light's polarization, researchers found signs of anomalous vacuum polarization. According to quantum field theory, empty space is never truly empty. It teems with virtual particles that blink in and out of existence. But in this region, these particles behaved as if they were real and persistent, Dr. Sabine Hossenfelder, a theoretical physicist, said it was as though the boundary between virtual and actual matter had temporarily vanished. This phenomenon could support radical theories attempting to unify quantum mechanics with general relativity. Loop quantum gravity suggests that space is made of discrete units, while the ER-EPR conjecture posits that wormholes and entanglement are essentially the same thing. Another idea, causal set theory, claims spacetime arises from fundamental building blocks. According to Dr. Juan Maldacena, we might be seeing evidence of a deeper metastructure, a more fundamental layer beneath what we call reality. And the strangeness didn't stop with one galaxy. As news of Webb's discovery spread, astronomers began comparing data from other instruments. They found that during the same observation window, radio telescopes had recorded subtle timing anomalies from several quasars, supermassive black holes emitting powerful energy jets, located in the same part of the sky. Dr. Shep Doleman, who led the Event Horizon Telescope project, noted that these signals were mysteriously synchronized, despite originating from objects billions of light-years apart. No known force could cause this kind of coordination, except, perhaps, quantum entanglement. This raised a staggering possibility. While entanglement has been demonstrated in labs on Earth, the idea of it happening on galactic scales was previously considered impossible. But if true, it means the universe is connected in ways far beyond what classical physics allows. Dr. Nergis Mavalvala of MIT said this would blur the boundary between the quantum and cosmic, changing how we see reality itself. As physicists tried to make sense of it all, they turned to the ADS-CFT correspondence, a mathematical tool used to explore the holographic principle. This principle suggests our three-dimensional universe could be a projection from a two-dimensional surface. But when researchers applied this framework to the distorted region in space, the math didn't hold up. According to Dr. Leonard Susskind, a pioneer of the holographic principle, the information density observed in the region exceeded what should be physically possible. It was like discovering a 1 gigabyte flash drive storing 10 gigabytes of data without compression. This points to two extraordinary possibilities. Either the conservation of information doesn't hold in that region of space, or we've stumbled onto a more fundamental layer of existence. Perhaps, as Dr. Susskind suggested, we're witnessing data leaking into our reality from a deeper level of the cosmos. To understand how all of this began, we need to revisit Webb's original observation. During a 12.5-hour exposure of the galaxy, cluster SMACS 0723, Webb's first deep-field image, scientists observed thousands of galaxies, with one particularly distant galaxy perfectly lensed into an Einstein ring. These rings normally result in light arriving at different times due to gravitational time dilation, but one portion of the ring arrived significantly earlier than predicted and at a slightly different wavelength. According to Nobel laureate Dr. Kip Thorne, it was as if the light had traveled through a zone where time flowed faster, an effect completely opposite to what Einstein's theory would expect near massive objects. The findings didn't end there. When Webb's near-infrared spectrograph analyzed the same galaxy, it detected an emission line that didn't match any known atom or molecule. Every substance in the universe has a unique spectral fingerprint, but this line fell between known transitions of carbon and oxygen. It matched nothing we've ever measured in a lab. The spectral anomaly lined up precisely with predictions for the decay of hypothetical dark matter particles like axions, suggesting invisible matter had, for the first time, become visible. The mass distribution around the lensing cluster added another layer to the mystery. When researchers modeled how the cluster's gravity bent light, they found a mismatch between how matter and light curved spacetime. This gravitational slip defies general relativity, which insists that matter and light should follow identical gravitational paths. Dr. Tessa Baker of Queen Mary University pointed out that this phenomenon, while theoretically proposed, had never before been observed. It raises the possibility that either unknown forms of matter are influencing gravity in new ways, or that Einstein's theory needs a fundamental revision. In response to these astonishing developments, the global scientific community launched an unprecedented collaborative effort. More than 100 research teams around the world began analyzing the data, comparing it with archival observations, and devising new models. Dr. Natalie Batalha remarked that the last time scientists mobilized at this scale was during the hunt for the Higgs boson. But in that case, the discovery was expected. No one saw this coming. Major observatories are now scouring their archives for similar anomalies. Emergency panels convened by NASA and the European Space Agency are working to understand what the data implies for our understanding of gravity, dark matter, and the fabric of the universe itself. Some theorists are already calling this discovery the next major revolution in physics, comparable to the discovery of dark energy or perhaps even multiverse-level breakthroughs.